So, I know you're probably already all thinking it just from looking at the title, De-Extinction. What do we immediately pair with that? Well, Jurassic Park, of course. I'd be lying if I said this wasn't really the core reason that I wasn't interested in this topic. And this movie was always my favorite movie as a kid, and still is today. But there was always one idea from this movie that always really stuck with me, and that's the idea of taking these extinct animals that once roamed our earth and bringing them back into our modern world. And so you can imagine my surprise when only a few years ago I discovered there was an entire scientific field around just that, a field that had already made leaps and bounds and progress that really went quite untalked about. And that field is, of course, de-extinction. So what de-extinction is, I'll just give it a brief definition, is taking extinct species that once roamed our ecosystems, finding a way to bring them back and reintroduce them into those ecosystems to fill any gaps in niches that they had left after they went extinct. And so I want to start with really how this field started roughly 100 years ago in the 1920s and 30s with the studies of Lutz and Heinz Heck. Now what they sought to do was to bring back the auroch. The auroch is an extinct species of European cattle that died out in 1627 due to overhunting and the expansion of farmland. How they attempted to do this was by finding their closest known relative, which is just typical European cattle, and breeding the traits selectively to make a form of cattle that looks and acts like an auroch. And they failed miserably. They only had access to their physical traits and didn't have access to their non-physical traits. And obviously, with selective breeding, they couldn't choose what traits to pass down, and kind of ended up being a mess. Now, this was attempted yet again later in the 20th century with success, giving birth to the first Taurus auroch, a very successful attempt at de-extinction, and I'll touch more on that later and the effects that had. Now, the other really big step in the field of de-extinction was on July 30th in 2003 with the birth of a Pyrenean ibex. Now, the Pyrenean ibex is a mountain-dwelling creature that lived in eastern Spain until it went extinct in the 1990s. The last known Pyrenean ibex was in captivity, and it was just a female. Obviously, it could not pass on its genes as there was no male to make another ibex. And so what scientists did was they took a tissue sample from this ibex before it had died and preserved it. A few years down the line, they took a sheep, its closest known relative, harvested an egg cell from that sheep, and through a sophisticated scientific technique, they transplanted the DNA of the ibex into that egg cell and took out the sheep DNA, essentially making an ibex egg. They then took that egg, put it back in the sheep for gestation, and it gave birth to a Pyrenean ibex. Now, this calf only died a few minutes after its birth, but it came out fully formed and was a Pyrenean ibex in every single way that it could have been. However, it died due to a lung deformation, as this was 2003. It's a very new science, and obviously we're still even experimenting with it today. And officially, the ibex is the only species to have ever gone extinct twice, which I think that's pretty interesting. And this is only 2003. I mean, this is 20 years ago. So let me go into some of our more recent findings in this field. In 2019, a Russo-Japanese scientist team brought back a 28,000-year-old mammoth cell from the permafrost and essentially brought it back to life, almost like a little Frankenstein wriggling around in the lab. And just the age of this cell is really hard to grasp. I mean, this is older than civilization itself, and we unfroze it and made it live again. And even though this is just one cell, it's really a very important stepping stone in bringing back an entire animal. especially one as old as the mammoths. And if you think 28,000 years is old, well, in 2021, we discovered and analyzed mammoth DNA that was over 1 million years old. Now, this was by far, at the time, the oldest DNA ever found and analyzed. And if you notice, I use the word "at the time." That's because in the next year, in 2022, we discovered 2-million-year-old mastodon DNA, and as well as 24 new plant species in northern Greenland. Now, these plant species weren't even known to have lived in the region, which made it especially an important scientific finding. And yet again, I mentioned plant species when I've only been talking about animals this far. And that's because this field isn't just limited to animals either. We can bring back extinct plant species as well. In 2012, there was a beautiful flowering plant known as Stenophylla, a flower that had been extinct for thousands of years. But scientists found a large number of seeds in the burrow of an extinct species of Arctic ground squirrel. And they took these seeds that were frozen in the permafrost and fertilized them, which led to this flower right here. Now, this is the oldest flower to have ever existed, and really, it's quite beautiful, honestly. I'd love to have one in my house personally, but I don't work for any scientific team, and I'm not a billionaire. And this is really a huge step for de-extinction to bring back a plant from this far back. And these are only some of many of the scientific studies and achievements in this field. And we could see the return of many, many more animals than the ones I've already mentioned. And I just want to give a quick rundown just to give an idea of how many that is. So we could see the return of animals such as the woolly rhino right up there, the short-faced bear, the moa bird, Smilodon, the Caspian tiger, the dodo, the mamo, the passenger pigeon, the Tasmanian tiger, the elephant bird, the quagga, the North American lion, the mammoth, and Steller's sea cow. I mean, that is an amazing amount of animals, and that's just really scratching the surface, to be honest. Now, of course, I haven't really mentioned the big question, and that's, what do we do with these animals once we bring them back, and more importantly, why? And really, the answer is, as previously mentioned, to put them back in their respective environments. And this can have amazing impacts, not only on those individual environments, but also, surprisingly, on the global climate. Now, I'm specifically referring to a project known as Pleistocene Park, which is in the far reaches of eastern Russia in Siberia. Now, this park is only 16 square kilometers large. And in that park, there are now bison, ox, moose, reindeer, horses, and eventually mammoths. Now, what this park hopes to achieve is to restore the ecosystem that once thrived in Siberia before humans came along and did some funny things, as we typically do. We overhunted the mammoths, and the mammoths were a keystone species in this region that really helped protect the grasslands that thrived in Siberia. Now, these grasslands acted as a huge carbon sink on Earth, and along with that, protected the permafrost, which resides below the snow in Siberia. Now, why permafrost is important to the global climate, I'll explain right here. What permafrost is a thin layer of ice below the snowfall in the Arctic regions of the Earth. And increasingly, as the Earth has been warming, this permafrost has been residing year after year. It's been shrinking. And as this permafrost shrinks, it releases methane gas due to the plant matter that had decomposed under that permafrost thousands of years ago. And methane is 25% more potent as a greenhouse gas than even carbon dioxide is. And there is huge amounts of this under the permafrost. And so it's really a terrible cycle where this permafrost is melting, releasing more methane gas, which heats the climate more, which releases more methane gas as the permafrost is melting more, and et cetera, et cetera. So we really need to prevent this permafrost from melting. Now, how does a group of mammoths have anything to do with that? Well, with the grasslands returned in Siberia after mammoths and these other grazers can roam freely, what they do is, as grazers naturally do, is search for food, and that requires lots of walking. And that walking compresses the newly fallen snow everywhere. And we're all from, I'm sure most of us are from Ohio. We deal with snow all the time. And you know from that snowman you built in first grade, or even from just stepping in the snow, that compacted snow lasts a lot longer than any non-compressed snow. And just this simple concept of compressing the snow to make it last longer adds a huge layer of protection on this permafrost underneath Siberia. And along with that, the grasslands of Siberia act as a much better carbon sink than just snow. And this is only one idea that can help curb climate change and protect our global environment, when de-extinction has many other uses. In Europe, going back to the aurochs, those Taurus aurochs that I mentioned previously have already been released into many areas of Europe where the environment is kind of really struggling and niches are unfilled that can be filled by these aurochs. They have been released in Croatia, Spain, Portugal, the Czech Republic, or Chechnya, and more recently in 2020, Romania. And these species have had enormous successes in these areas and have been really spreading their positive impact far and wide, of course under a controlled setting. Now, despite all this amazing progress and a lot of these prospects, there's also a great deal of criticism in the field of de-extinction. And I'll be focusing on two main counter-arguments against de-extinction. Now, the first is many of these species have been gone hundreds, maybe even thousands of years from their respective environments. So how can we say for certain that there won't be any unintended consequences? And while it is true that it can be hard to predict, if we mandate de-extinction methodically and thoughtfully, I don't see this as being a huge issue. And that's because in the global time scale, nature adjusts quite slowly to change. Evolution takes millions of years. And really, the only reason things have been dying out so quickly now is because of human influence. And so when a lot of these species went extinct, there has been no animals yet to come have taken their place. And these left open niches in the environments have really just been prone to disaster for the entire environment and leads to an instability that is unmatched. And so by bringing these species back in, they fill those niches which they once filled and are now protected by conservation efforts. They can really lead to a huge positive impact on their respective environments. And the other main argument is that the field of de-extinction will draw resources away from current conservation efforts. The line of thinking here is, if we can bring an animal back, why protect it in the first place? Why protect endangered species if we can just make them in a lab? And while I think it's definitely true that we need to use these resources used to protect these currently endangered animals to ensure that reintroduced animals can get a foothold in their respective environments, I think that a lot of these species will reestablish the stability which causes a lot of these animals to be endangered in the first place. And the benefit that we get from using these resources for de-extinction will be equal to, if not greater than, how we are using them already today. And I truly don't see a way in which this field would make people care less about the environment. And also, if anything, I would say this increases public interest in this topic, really because this is such a science fiction concept brought into reality. It's something that we don't often hear about, but I do think we will be hearing about it a lot more in the coming decades. And so, how I want to finish this off, really, is I think de-extinction is a very worthwhile concept. I think we will be seeing it more and more. And I think that the best way that we can approach current changes to our climate is by looking at how it used to work and how we can actually use how it used to work to fix how it is now. And so, once mammoths again sound their mighty roar and roam the grasslands of Siberia, and when the aurochs once again spread into the now deserted areas of Europe and spread their positive impacts, I believe it'll be a new beginning, a new era for nature, a new era for the animals of the old. Thank you.